Today I am going to be talking about wingsuit flying. Wingsuit flying is an extreme sport that involves flying through the air wearing a special jumpsuit with fabric parts to simulate wings, perfected in the 1990s. The flight usually ends with the opening of a parachute, so the suit has to be flown from any point that accommodates sufficient altitude for flight and parachute deployment. In 1999, the first commercially available wingsuit, the Birdman Classic, hit the market. It was designed by Croatian Robert Peknik, who commissioned the first ever wingsuit instructor program. The basic physics involved in a wingsuit flight is the simple flight theory involving lift, drag, weight, and acceleration. The first force shown is acceleration, the forwards movement. Being on Earth, the flyer's acceleration will be 10 meters per second squared. The force acting against the flyer's acceleration is drag, or air resistance. This slows down the flight considerably. Lift force is the most important, as this is the force that keeps the flyer in the air. It is generated by the curvature of the wings and the airflow against the person. The final force acting on the wingsuiter is his weight in newtons, generated by the Earth's gravitational pull. This also affects the lift. This velocity time graph plots the flight of a wingsuiter. The first phase is his acceleration through the air, shown by the curve that gradually flattens out. This leads on to him reaching his terminal velocity, because all his forces are now balanced. Then, the abrupt change in speed is the opening of the parachute, and he slowly decelerates until he lands. However, like everything, wingsuiting, as you have probably already guessed, isn't exactly injury-free. The most evident accident possible is, of course, death. Wingsuiters have been known to fly at 37,265 feet and up to speeds of 226 miles per hour. A parachute or jumpsuit failure is fatal whilst wingsuiting. Before each flight, you should always check all parachute equipment and the suit to avoid any mid-air accidents. The other, less likely accident is the occurrence of G-lock, G-induced loss of consciousness, that is more commonly experienced by fighter pilots performing high-speed maneuvers and turns, such as this Russian Su-35 jet executing the Cobra maneuver. G-lock is caused by blood pooling in the lower body and not being able to pump back up to the brain, due to large G-forces being experienced. The pilot therefore blacks out. The problem of G-lock was solved by the creation of anti-G suits in 1941 by Wilbur R. Franks in Toronto. These suits used water-filled bladders to pump blood back up from the lower body. In 1943, the GPS anti-G suit was released by US military. It used air-inflated bladders, and this system is still in use today. However, the occurrence of G-lock in wingsuiting is so infrequent that the introduction of anti-G technology has not been officially incorporated into the suits. The way wingsuiters are able to fly is by using the upwards force known as lift. Lift happens when the airflow flows over the airfoil or the wings and creates a low pressure area behind the wing. Then the airflow underneath the wings angle pushes upwards and the air flows up into the low pressure area, creating lift. As time progressed and we began to understand the features of human flight more, wingsuits went from looking like this to this. Today's wingsuit is based off the physiology of the flying squirrel, with wing-like surfaces between the arms and the waist, and also between the ankles. This extra surface area allows sufficient lift, and the material is flexible to create the rounded surface of an airfoil needed for lift during the jump. The arms have easy release zippers so the user can deploy the parachute easily by pulling on a toggle with his now free arms. The suit is light and durable to withstand low temperatures and strong winds. Wingsuits are available in one-piece or tri-wing variants, the latter having 3 separate wings to attach. The example shown is a one-piece wingsuit with full body zippers for easy release. Thanks for watching my video.